Namaskar friends, myself Dr. Ashwini Kumar Gupta. Today I'll be taking a lecture on general organic chemistry. This general organic chemistry to some part we have read in class 9th and class 10th, where we have seen that the basic element or the basic atom to be considered in general organic chemistry is carbon. We have also seen a property of carbon. Why only carbon atom is considered? First thing, first thing which we have read is known as tetravalency. Second one is known as catenation. These are the two properties of carbon atoms. Now tetravalency matlab it can form four bonds with other elements. Second thing, catenation effect. Carbon has a unique property of combining itself with other atoms like carbon itself or nitrogen or oxygen, etc., and thus forming a series of organic compounds. Which is termed as catenation effect. So I can say, what do you mean by general organic chemistry? It is nothing else but study of carbon compounds. Now as we know, in a chemical reaction where bonds are broken and formed, that is, products are formed. Now why does this happen? Why there is a breaking and the formation of a bond? That means here electrons are transferred from one atom to other. That is, this is a movement of electron. This movement of electron is also known as mechanism. So what do you mean by reaction mechanism? It is nothing else but sequential movement of electrons from one atom to other, leading to a breaking and formation of bonds. Right? Sequential movement of electrons from one atom to the other, leading to breaking of bonds and formation of new bonds, that is products. This is known as mechanism, or to be more precise you can say it is a reaction mechanism. Yeah. Now as we know, atoms contain electrons. In the outermost shell, as we have read, or the valence shell. For example, we will see carbon atom. It has 4 electrons. Now what happens? It can share these electrons with other carbon atom. That means there can be either a sharing of electrons or transfer of electrons. Sorry, the spelling happens to be wrong. Or transfer of electrons. This sharing of electron between two atoms is known as covalent bond. And this is known as ionic bond, as we have read in class 9th. Ionic bond or electrovalent bond. And we know what do you mean by bond. Bond is nothing else, it is a force of attraction. Simple. It is a force of attraction between two atoms. Okay? The in detailed part of it we will see in the further lectures. Now, we have seen when a carbon atom shares its one of the electron with some other atom, for example hydrogen, it has 4 electrons. When it shares this pair of electrons, then this will look like this. Or we can also write as, similarly here the hydrogen happens, here the hydrogen, and here. Now, I will say this is a single bond. Single bond means one electron of carbon and other electron of hydrogen. That is sharing of 2 electrons. Single bond is also known as sigma bonds. Similarly, this is oxygen. This also has the 2 lone pair of electrons. Now this. So this forms O with somebody, and this double bond. This is known as double bond. That is sharing of 4 electrons amongst each other. Okay. This is known as pi bonds, and it's also written as pi bonds, right? Wait a minute, something. Yeah. Similarly, when carbon atom, when it combines with 3 electrons of an element, take for example nitrogen, it gives rise to C triple bond N. This is also known as pi bonds or triple bonds. Triple bond. That means sharing of 6 electrons amongst the atom. Triple bond is also known as pi bond. That means we can say double and triple bonds are known as pi bonds. Collectively we can say. Right? Yeah. Now we will see some different part, where we will see the different types of structures. Different types of structures now. Now we will see first one is happens to be dot structure. That means carbon, hydrogen, yeah, you can say right. This is known as carbon. Dot structure. These are known as dot structures. The second thing happens to be dash structure. From the name itself, we can understand dash structure. Now, as we know, these two electrons combine to form one single structure. In the previous slide, I have told you. Right? Similarly, one hydrogen, and one hydrogen. Now, third one is the condensed structure. Now, what do you mean by condensed structure? Take for example, this is H, or this is OH, this is H, this is H, this is another H. Condensed means one carbon and 1, 2, 3, 4, CH4. This is C1, 2, 3, CH3, which is bonded to OH. OH. Condensed form. I hope you might have understood the part till what I have taught you. Yeah. Now, we'll go for the next form. The other form is known as bond line form structure. Sorry. Bond line structure. Now, what do you mean by basically bond line structure? It is nothing else, same thing. Take for example, first we will go from the starting. Suppose H and another H. Now, this is the condensed structure will be what? CH3, then CH2, CH2, CH3, CH3, CH2, CH2, and then this is CH3. This is nothing else but the condensed structure. Now, what do you mean by bond line structure? Nothing else. We have to write it in terms of lines. This and the meeting point of two lines are known as carbon, and this carbon is bonded to two hydrogen, which is understood that there are two hydrogens because carbon has 4 valency, 1, 2 and 2 hydrogens. So this is CH2. Take for instance, this is CH2. Similarly, this is the other CH2. Sorry, some mistake from my side. Yeah, CH2. Now, is this side connected to somebody? No. If it's not connected to somebody, then it is CH3. CH3. CH2. This will be written as, right? So this is the bond line structure. Now, The another form is known as three-dimensional structures. अथवा 3D structure. 3D structure is three-dimensional structure. We will write as 3D structures. Now, what do you mean by 3D structure? We know that everything in this planet is in a 3D form. 3D form. That means if I see something, if I see any matter, I'll be able to see the whole 360-degree view of all the sides. All the sides. Take for example, methane, which I'm writing as CH4, CH4, I'm sorry, CH, right? This structure, I can say, this is written in the plane of paper. Or a 2D structure. 2D structure means it is written in the plane of paper. Now, as we know, obviously all the hydrogens can't be in a straight fashion in 2D structure, because naturally it has to be in 3D form. So possible it can be like that. It can be. This is known as solid wedge bond. That means the bond, the particular bond is pointed towards the observer. And this is known as dashed bond. Or bond pointed towards, extremely sorry, away from observer. Right? So this is nothing else but 3D structures. 3D structure. Now we will see some of this classification. Yeah, that was the structures. Now we have to see some classification of organic compounds. Now, what do you mean by classification of organic compounds? Classification of organic compounds means in what shapes the organic compounds do exist. In what shapes do organic compounds exist? First one happens to be acyclic, or you can say no cycle, or aliphatic. Right? Now, in that acyclic, or you can also say aliphatic or open chain. For example, CH3, CH2, CH2, CH3. Aliphatic matlab straight chain. That is straight chain. Straight chain. Fine. Now, the other type will be cyclic. Fine. Cyclic. Now, cyclic will be two types. One will be homocyclic and the other will be heterocyclic. Now, homocyclic is also known as carbocyclic. Now, what do you mean by homocyclic? Homocyclic from the name itself means same. Same. Take for instance, this is a 6-membered cyclic ring. 6, 1, 2, 3, 4, 5, 6. 6-membered cyclic ring, and all the groups are CH2, CH2 and CH2. Fine? Yeah. Similarly, it can be a 3-membered or a 4-membered, whatever. Right? Or it can be a 4-membered with a double bond. Right? Okay. Fine. Now, in homocyclic, there are two types of compounds. One will be aliphatic, other will be aromatic. Take for instance, in aliphatic means it will be no double or triple bond, means all the atoms are same, CH2, CH2, CH2 and CH2, or a 4-membered, right? Yeah, it will be one cycle. Okay. Now, aromatic. The best example for aromatic means, what do you mean by it? It will be a double bond, single bond, double bond, single bond. Means it will be alternate sigma and pi bond. That is single and double bond. Example is benzene. Example is benzene. Now, this happens to be there. Or you can also say benzene, if suppose if you write as CH3. This is known as toluene. Now, in aromatic, accordingly, there can be a monocyclic or dicyclic or many other. It can be a simple monocyclic or it can be a dicyclic also. Take for instance this. Fine. A dicyclic and a tricyclic also accordingly. Okay. Now, one is known as heterocyclic. After in homocyclic, one is homocyclic in cyclic compounds. There are one is homocyclic and the other is heterocyclic. Heterocyclic means what? Heterocyclic means they are closed chain structures. They are closed strain structures, closed chain structures. This is double, single, double, single. That means this is a closed aromatic structure, but this is closed but a non-aromatic structure. Are we able to find double bond, single bond, double? No. So this is non-aromatic and this is aromatic. But what is the difference now? If a 6-membered to this is attached, take for instance a oxygen atom, right? I'll just right, oxygen atom there, and one double bond here, one double bond here. This which is known as pyran. Obviously this is not an aromatic. Now other comes aromatic heterocyclic. Take for instance suppose there is nitrogen. This is known as pyridine. Now pyridine. So this happens to be the simple plain classification. As and with we go forward, we will see much more come. But the basic thing you should know, what do you mean by heterocyclic, right? Now we'll go to the another topic, classification carbon atoms. That means, see, now this is the carbon atom. This is bonded to another carbon atom, right? Take for example, I'll write it as CH3 bonded to CH2 bonded to CH3. Now this carbon atom is bonded to only one carbon atom. So this carbon atom is known as primary carbon atom. Which is donated by one, not superscript. Now this carbon atom is bonded to two carbon atoms. So this will be known as secondary carbon atom. Which will be denoted by 2 dash. Now similarly, suppose if I write like that, this carbon atom is bonded to 1, 2, 3 carbon atoms. So this is known as tertiary carbon atom. Which is denoted by tertiary. Right? Now, and similarly when carbon atom is bonded to all the 4 carbon atoms. So it is known as quaternary carbon atoms. Or 4. Now the all-in-one example will be CH3. Combine all these things. So I will say this is a tertiary carbon atom, this is a secondary carbon atom, and this happens to be a primary carbon atom. Fine. Now, primary, secondary, and another primary. Now, when one carbon atom which has 3 hydrogen atoms, one carbon atom has 3 hydrogen atoms. Similarly, if I want to do classification of hydrogen atoms, now in classification of hydrogen atom depends on the attachment to itself, attachment to the carbon atom, which carbon atom it is attached. No. Take for example this C. This is H, this is H. So this carbon atom, you can say, similarly this carbon atom, they are known as vinylic carbon atom. Vinylic hydrogen atom. Vinylic hydrogen atom. There is something called alpha carbon atom. Then beta carbon atom. Right? Now, what do you mean by alpha carbon atom? Suppose CH3, CH2OH. CH3, CH2OH. Now, this is the OH group. It is also known as functional group. At present, you just come to know this is fun. In the next topic, I'll be teaching you what do you mean by functional group. Functional group. The carbon atom which is next to a functional group is known as alpha carbon atom. Alpha carbon atom. The carbon atom attached next to the functional group. Alpha carbon is not carbon attached next to functional group. Now, what do you mean by beta carbon atom? The carbon atom attached to an alpha carbon atom. Carbon atom attached to a alpha carbon atom. Understood? What do you mean by alpha carbon atom? Alpha carbon atom which is attached next to a functional group, and beta carbon atom, carbon attached to a alpha carbon atom. Right? Now, similarly, the hydrogen atoms of an alpha carbon atom are called alpha hydrogen atom. Just make it a point. Hydrogen atom attached to an alpha carbon atom. That means these two hydrogen atoms. These two hydrogen atoms, they are known as alpha hydrogen atom. Similarly, these three hydrogen atoms are known as beta hydrogen atoms. To beta carbon atom. Fine? Yeah. Now, another very important part we will do now. Another concept. Just students tell me, a chemical reaction takes place, right? Now, what is the particular reason for a chemical reaction to take place? There are some groups or a combination of different atoms which form a particular group, and those group when attached to the carbon atom, try to understand. Suppose carbon, hydrogen, hydrogen and hydrogen. Now, the atoms which are in groups are attached to some substrate, a substrate. Take for example NH2. It is not carbon. Okay? This NH2, or I'll say CH3 attached to OH. That means this is a group of atoms which results in atoms when attached to hydrocarbon, leads to the reactivity of the compound. This is known as functional group. For example, MH2, N has 3 valency. This valency is attached to some carbon, any hydrocarbon. Similarly, NO2, this is attached to some. Similarly, COOH. That we will see there are many other groups. COOR, the expanded structure will be CO. It is double bond O and then OR. C double bond O and OH. Now, what do you mean by this term called R? R is nothing but alkyl group. What is this alkyl group? When from an alkane one hydrogen is removed, that means alkane minus a hydrogen atom, that means one hydrogen atom. That means alkane, methane minus one hydrogen atom leads to formation of CH3, which is known as methyl. So C double bond OOR. Okay? Now we will see some examples of functional group. I think so you have understood what do you mean by functional group. Functional groups are nothing else but group of atoms which when attached to hydrocarbon leads to the chemical reactivity of those hydrocarbons, right? Now there are few examples. OH, Example, we can say CH3OH. OH is known as alcohol, right? NH2 is known as amine. NO2 is known as nitro group. CHO is written as C double bond O single bond H. This is known as aldehyde. COOH, C double bond O H. This is known as carboxylic acid. Then COOR, R is it methyl group, ethyl group. From ethane is, if ethane is the hydrocarbon, if you remove one hydrogen atom, then it will become ethyl. That means in general, as I have told, alkane minus one hydrogen is known as alkyl. That alkyl can be methyl, ethyl, propyl, butyl, anything. So this is known as ester. Okay. Now C double bond O, and here it is C, and here it is C. Matlab C, a C based compound, some alkyl group is attached, which is equivalent to R, C double bond O, R. This functional group is known as ketone. Fine. Now C double bond O NH2 is known as amide. C triple bond N is known as nitrile. And many more functional groups we have. Okay? But the initial basic part of a functional group I have told you. But they are also, the name of these depends. The name of the functional groups, the name of the function which I have written you, that they have their prefix name also and suffix name. Now what is this prefix and what is this suffix? I will explain you in the next chapter. Next topic. Now, if you have any problem, any question, just write in the comments the questions which you want to ask me. Okay, so now I shall take a leave. Thank you very much. Please do subscribe my channel, and just subscribe it and follow it on Instagram, then on Twitter, then Facebook. You can even WhatsApp me on the number which I have mentioned on the thumbnail. In the thumbnail you might see a number. From that you can let me know. Okay, thank you, thanks a lot, bye.